Hi, this is Mr. Max. I am looking at the grade 11 paper of the Khomas region. This is paper 1, and I haven't yet worked it out myself. So, what we are having over here is I am seeing the real time paper just like you. Okay, so we're going to take it question by question. It's supposed to be out of 80 marks. And this is all in the attempt to assist you to prepare for the finals. Now, let's see here. This first question says you are supposed to calculate that using your calculator. So obviously, just go ahead and use your calculator. All right, so that is 13 minus the square root of 5 and all squared. Okay, and that answer is what you're going to be writing. So full calculator display over there. All right, so I'm just going to put it over there as an answer. Maybe I should do this, and okay, so that's my answer. You got it? Right, it's from my calculator, so you'll be using yours. Then write as an ordinary number. Again, it's 1 mark. Don't try to overthink a problem like this. All right, if you're confident in working without using a calculator, of course, this is 3.4 times 10 raised to the negative 2. You don't even have to, if we use this function, you don't even have to say raised to the power of. So what that is 0.034. So you can also just as well have that answer. Of course, it's 1 mark. Don't try to overthink the problem. As I was saying, you just move on to the next one. From the list of numbers, we are supposed to write down a multiple of 7. The multiple of 7 here is 42. That is 7 times 6. Oh my goodness. So this is 42. The answer there. You must use the list, the numbers in that list. A cube number, right? A cube number is 8, because the cube root of 8 is 2. So 2 times 2 times 2 gives you 8. So 8 is a cube of 2. A prime number, this is supposed to be from memory. You should know this. Prime number in that list is 23. Okay, it's a number that only has exactly 2 factors. That is 23 and the number 1. And then from there, the square root of 64. You can, if you don't know, the square root of 64 is nothing but 8. So I see that we are using 8 twice in this question. So cube number, well, this is not the only cube number that you have over here. Okay, you also have this number here. This number is also a cube number because the cube root of 125 is 5. So another student could have used 8, or they could have written 125. Any one of these would do. Okay, any one of these will do. So there are 2 possible answers there, but you of course only will be writing one. So 125 is also a cube number. All right. The reason why I went back there, sometimes you have to be careful if you use something twice, check whether you didn't make a mistake. All right. You have to write this in descending order. That's starting like you see the biggest number. So the smallest number, of course, and then you're going to go in that way. Smallest number, you start with the smallest number. So descending order. Sorry, my bad. So if you're saying descending, so if I write descending, that is 6 is less than 5 is less than 4. This number and descending order. So when you say descending order, these are supposed to face the other way. Okay, naturally, they must face the other way, right? Unless now, in this particular question, we have to start here with the descending order, where we take the number here, that number will be smaller than the next number, will be smaller than the next number going in that direction. So I guess maybe that is what they were asking us to do there, or this could be a mistake, I don't know. So first thing is to try to rewrite this as decimals. Is easy to compare place values. So that's 0.02. That's what this one. This one is 0.2. This one is 0.25. Now, obviously, if you have to look at which number is bigger, then all of them are 0.2, so you're going to go to the next place value. So this is the first number that is bigger. So 25% is bigger, okay? So it will be the biggest number, followed by um, this one over here because of that 2 at the hundreds place. Remember, this is just 0.20. So we go to the next hundreds place. Tens compared, now we look at hundreds. Okay, I mean, we compare the tens, the hundreds we compare, and we realize that one is exactly the same. So when we look at this is 0.25, then the next one should be 0.205. So this one is the next number, right? Okay, that is bigger. So this is what's going to be the second in my list. Oopsie, let me just, that is going to be second on my list. Okay, and the third one on my list is going to be this one over here. It's just 0.3, and this one is the smallest one. Okay, so this one will be the smallest one. In fact, this one has no tens, only 200s, no tens, 200s. So if you look at that, this is a very small number compared to that number over there. All right, so the biggest one, so when we say descending, so the biggest one, starting with the biggest one, then the second, this number is bigger than that one, is bigger than that one. Okay, I'm already also getting confused over here. The biggest number, so we need to start with a small number. Yeah, the biggest number. This number is going to be bigger than that one. That number will be bigger than that one. So if we take this number over here, which is the first number, that is 25%. 25% is bigger than, what is the second number that I put over there? It's 0.205. That number will be bigger than, what is the next one? This is descending order, okay? So what is the next number after that? 0. We say third. Okay, you write the number as they were, and then obviously the last one, which is 2/100. Do not write your change values, the decimals or percentages, whatever you want to use to compare those numbers. You must use the original numbers like so. Okay. If you read it, I guess, from this side, this is smaller than that one, this is smaller than that one, and this is smaller than that one. All right, so perhaps nothing wrong with that. 280 as a product of its prime factors. Now it's 2 marks, so I'm just going to use the calculator. Of course, if you don't know how to use the calculator, all right, you can always go the long way. So this is 2 cubed times, just going to have it over here. This is our answer there. Okay, right, so obviously you'll be doing that long way if you don't know. Okay, you know, starting with the first prime number. Hopefully you are familiar with that method. You start off with this, and then you can either write, you know, your number on the left or the right, doesn't really matter. So if you were to write on this side the 280, and then you start with the first prime number, and you decompose them, you're going to use 3 of them. Okay, so that's the second, that is the third. We're going to use the 5, and we're going to use the 7 once. Okay, now it doesn't matter. So half of that is 140, use half of that is 70, use half of that is 35. Next prime number is 5, goes there 7 times, and then 7 goes there. So these numbers on this side, is actually what is written over here. Let me just write them in index form. All right, highest common factor, so we know 280 is equal to 2 cubed times 5 times 7, 126. Well, let's do the same for 126. We're just going to say, okay, what is 126? 126 press equal to, and then it's 2 times 3 squared times 7. So 2 times 3 squared times 7, just to compare, 2 times 3 squared times 7. Now the highest common factor, we're just going to look at what is common here, and we're going to take the ones with the smallest power. So the 2's are common, so 2 raised to the power 1 will be the common one that we are going to choose. So the highest common factor is like 2 to the power 1. There's a 3, there's no 3 over there, and the next one that we're going to choose is just going to be the 7. So this answer is just 2 times 7, which is 14, and 14 is the highest common factor. Right, what we have here, after a 20% discount, a jacket cost 452. The original price we don't know. So this is a question on the reverse percentages. So what is it that we know? We know that this 452 represents 80% of the original. Because when you are doing a discount, you say 100% minus 20% is 80%. Okay, so what you have over here, this representation, this 452 is actually equal to 80%. That is what it equals to of the original amount, which we don't know, 452. So we don't know what this amount is, so I'm just going to call it x. So this amount, as you can see, comparing the denominators, is supposed to be bigger, right? Because you might not know, okay, this is a question on reverse percentage, but working in that way can definitely assist you. Now, if you were to cross multiply, you have to cross multiply this one. That gives you 80x. And if you were to cross multiply these two, I'm just going to put 100 here, and I'm going to say times 452. Then how do you solve this? You solve this by dividing throughout by 80. So you see where the 80 is coming. That's the concept of reverse percentages. So this is the concept of the reverse percentages, right? The 100 is always on top, but that's where it comes from, right? So it's just 100 over 80, and then you simply multiply that with 452. Okay, so that's 565, and that is our answer over there. So the original 565, that is supposed to be the original amount. Okay, that is supposed to be the original amount because it should be bigger than the discounted amount. Does that make sense to you? Right. Suppose you are getting confused. This number is 14. So let me just clean this up a bit so that it doesn't look so confusing to you, since I'm putting things in clouds and squares and so on. On Thursday, the temperature was 2 degrees Celsius. On Friday, the temperature fell. From 2, it fell by 5 degrees Celsius. So we'll draw the temperature on that. It's going to be -3 degrees Celsius. Okay? That is the answer over there. If you have to, maybe I should not use that. So let's see if every time I'm going to use the arrow to indicate that is my result. Convert 13 meters per second to kilometers per hour. Okay, 1 kilometer is 1,000 meters. 1 hour is 60 times 60 because we want to change it to seconds, which is 3,600 seconds. So you are going to move. So basically, you're going to move. We're going to change 13 meters. So if you now have to go, remember, you have your kilometer here, followed by your meter, centimeters, and so on and so on. So we are going from meters, we're going back to kilometers. So that implies that we need to divide. Okay, we need to divide. Obviously, we're going to be dividing by 1,000. So the number on top, the 13, should be divided by 1,000. So that is going to move it from okay, it's interesting what I'm seeing over here. That's going to be that because the smaller unit to a bigger unit. And then the next one that we have got this 1 second that we are supposed to write in terms of an hour. So 1 second is 1 divided by 3,600 because that is what 1 second represents. And grab your calculator, and then you have 13 divided by 100. Let's see if it's okay. Let's just first have that 13 divided by 1,000 rather over 1 divided by 3,600. Okay, that answer is 46.8. So that is 46.8. And that answer is in kilometers. Now, you might have calculators that have got that programmed in them. Just want to see. I think it's maybe I'm converting. Let's see if we take 20. 20, so that's meters. Okay, so we have got 3 meters per second, and I'm going to convert it to kilometers per hour, and then 3 meters per second is 10.8. So let's quickly see. Oh no, it's not 3 meters rather, Mr. Max, it is 13. I was now wondering. So that should be 13. Right, hit enter. Of course, you see the answers are corresponding. Okay, but you don't have the luxury of that, but just to show you how to get the answer. Right, 2 marks, less than 2 minutes, okay? Chris invested 5,200 at a rate of 3% compound. Whenever you get these questions, it's always important that you highlight the information that you give. So a lot of times you see students reading a compound interest question and then they use simple interest to follow, to solve that. And that could be really tricky there if you are struggling with that, okay? And then we have the rate, we have the principal amount, and the interest. The interest is always supposed to be in years, so do go and write this in years. 24 months is exactly equal to 2 years. So they ask us to calculate the interest, not the amount. So there are many ways you can do this. And when you use the compound interest formula, this formula over here, the P open bracket 1 plus, what is it, R over 100, times n or t, n with number of years. This is giving you the amount. That means the interest is already in this, okay? But we don't want the amount. So we're going to be subtracting the principal in there because we are looking for the interest. We are looking for the interest, okay? So that's what we are looking for. We're looking for the interest. So we're not looking for the amount. So this is what we're going to use. We're going to say the interest, because that's what they are saying, calculate the interest, is equal to, yes, 5,200, open bracket, 1 plus, our rate is 3%, and it's 2 years, but we're going to subtract that 5,200 again from it, okay, because we are looking for the interest, not the amount, okay. The other formula is different. For simple interest, you do the opposite. There you will be adding the principal to find the amount, okay. So that's why you have to be slightly careful when you are doing this. 1 plus, so that's 3 upon 100, and that is for 2 years. You can't be putting 24 months there, and then you're going to subtract the 5,200. Of course, you can show them step by step, and that answer 316.68, 316.68, okay, not 8. Let's undo that, 0.68, and that is our solution. So you might have calculated an answer where you did not subtract the principal from that, and this is what you might have. Of course, you start losing marks because the question is not asking for that amount, the question is asking for the principal. So you should definitely show your steps whenever you are deciding to go that route where you're working and taking things and writing down everything as it is. Right, so implies you should know the formula, of course. Right, the distance between, let me just bring in a red color, between Marienthal and Windhoek is 270 kilometers. At the moment I know this. I don't know where this two significant figure is so far, social distance. All right, so it's supposed to be two significant figures. Whenever you are told something like this, two significant figures, look at the place value of two significant figures. So you have the number 270, the place value of that second significant figure there, that is the 10th position. So what you're going to do, you're going to say, okay, 10 will be divided by 2. I'll be adding and subtracting 5 to get my upper bound and my lower bound to that number. So the upper bound is nothing but 270 add 5. So this is 275. The big number always comes to the right side, okay? Remember that, 275. And when you subtract 5 from that, that's going to give you 200. And so the lower bound and that is going to be 270 minus 5, which is 265. And that is basically what you're supposed to do. Write them in the correct order so you don't go and lose marks. Okay. Right. Question 11, they say y is directly proportional to the square of x minus 3, the square of that. So this implies that I'm going to have equation y equals to k, some constant of variation, times x minus 3 all square. So the reason why they give you these values here are not those ones that I have highlighted at first. This one's over here is they want you to find the k value of k, and then they will ask you either to find y or to find x. In this case, they want us to find x when y is something. So before you do anything, you are going to substitute, the value, because when x equals to 2, y equals to 5. So 5 over here, constant of variation, x is equal to 2. Take away that, right? This is 5 is equal to k. You get negative 1 here, and anything you squared is just going to be 1. So that implies that k is equal to 5. So our equation now, our complete equation is y equals to 5 being the value of k, and then I have x minus 3. So now that we have our equation, right, set out, we can now use that equation to calculate anything that they want us to do. Here they say find x, they give us the value of y. So we're just going to substitute, right? We have got y is now 45 is equal to 5, x is what we are looking for, minus 3 all squared. Right, so if you do that, might be running out of space a bit, so I'm just going to create a bit of space for me over here. Right, so what you need to do is you need to divide throughout here by 5, and if you are dividing by 5 here and also dividing by 5 goes on 45. So this gives me x minus 3 all squared is equal to 9. I hope you can see where I'm going with that. Okay, so how do you get rid of that square? Of course, you take the square root of 9, and this is something that's proportional. Remember, we're looking for the value of x, and it doesn't really matter if you were to say the square root of 9 is equal to, because I know I'm going to write it out over here. This is what I'm saying. X minus 3, you're going to take the square root of 9. And then some learners will say, okay, but what if this answer is positive or negative? Because that's what you get. Let's say we go with that narrative for now. So x minus 3 is equal to plus minus 3. That's the square root of 9. All right. Then x is going to equal to, that 3 comes over. It's positive now, plus or minus 3. So let's see. When you have x is equal to, there are two possibilities. X equals to 3 plus 3, which is 6, or x is equal to 0. Because that's what you get when you're dealing with a quadratic equation, right? Maybe I must just append the page because I really want to get to the bottom of this one, right? So suppose we are working our equation. Remember, our original equation was y equals to 5, in bracket you have x minus 3 all squared, and we have got two solutions for x, right? And our y value is 45. That's what they gave us there, right? We see that y equals to 45. So let's see by means of punching in whether we're going to get this output. So I'm going to take this 45 away from now. See what is it that we're going to get if you were to place the one value. Let's say we start with 0. I take 0 for x minus 3 squared, right? This will give me 5 times negative 3 all squared. And here's the thing, 5 times negative 3. So negative 3 all squared is 9. Anything squared is positive. So this is 5 times 9. Surely it will be 45. So it works when you have 0 for x. Okay. And if you were to input the other value of x, which was, let's write the equation down again, 5 and then x minus 3 all squared. If x is equal to 6 here, this one was if x is equal to 0. We saw that it's working. So let's use this one to see what do we get. Okay, right, let's see if we do that. What are we going to get? So we have got 5 over here, 6 minus 3 all squared. Now 6 minus 3 is 3, so I'm going to have 5 is equal to 3 all squared. Anything squared, well, that's 45. So you can see that both the answer for x and for x is 0, x is equal to 6 seem to be working, right? So it's proportional to the square of. So this answer has got two solutions. Okay, x is equal to, and I hope people have it like that. X equal to 0 or x is equal to 6. For me, these two answers are exactly correct. There are two answers. The moment you are dealing with this square root stuff, and you have to take, the root of something, you have to be careful, and then you have to check. Okay, all right. So those are the solutions. There was no need for me to do all of this, but I just wanted to show you exactly that you do have two possible answers there, and you might think that, wait a minute, one of my answers is wrong, but I would say not really. So I would be saying find the values of x. That's how I would be writing that down to give the kids a bit of a hint. There are more than one solutions to that. Anyway, be as it may, we go to the next one. We are supposed to expand, and the way you do that is you're going to take this term and you're going to multiply this term with everything inside the bracket, and you must be careful when you do the second part. A negative times a negative will give you a positive result. So I'm going to write it like this: 5 minus 3x. Now take that, and then you're going to get, you guess right, you're going to get a positive. Okay, a positive what? A positive 6, because negative 3 times negative 2 is positive 6. So this would be 5 plus 6, which is 11, minus 3x, and that is the final answer for that. Just with 2 marks, you might get a mark for each one of those terms. Factorize completely, you need to take out the highest common factor, and if you take out the highest common factor being the 3y, and in brackets you're going to have y, and 3 goes into 12 4 times, okay? And the way you check yourself, it's just by multiplying back, and then you'll see, okay, wait a minute, I'm getting what I have originally. This is 3x. You are supposed to solve the following equation. So 51 take away 18, okay? You have a 51 take away 18, that is 33. Okay, the moment you get something like this, you can already smile your way to the bank, because you can already detect that x is going to be, that 33 should be divided by 3, which is 11. That's the answer. You got it? Then you are supposed to solve the following simultaneous equations. Right, it's 3 marks. You can obviously use many ways to solve this. I'm going to use the second equation, so you can go ahead and name your equation. So this could be equation A, and this could be equation B. Right, so what I'm going to do with equation B, I'm going to make P the subject of the formula. Right, the coefficients are not the same, so can I just go ahead and eliminate? Taking that 3q over, is going to be 3q, positive 3q plus 17, or 17 plus that, doesn't really matter. So what I'm going to do, I'm going to take this value and I'm going to substitute it where I have P in equation A. Okay, sub into equation A, I'm just going to write it down. Hopefully you do understand what I'm doing. So I'm going to substitute that P value, and then I have an equation only in terms of Q. So if I was to do that, I'll take this 3Q and plus 17. Okay, right, so it's now a matter of simply multiplying out. That is 9Q, and 17, that's 30 plus 21, that's 51, plus 2Q is equal to 7. You have got 2Q plus 9Q, okay, is equal to, so I'm adding the Q's together, is equal to 7 take away 51. 2 is going to be 11Q, and then if you say 7 take away 51, you should be getting 44, negative 44, and then Q is simply calculated by saying negative 44 divided by 11, so Q is negative 4. Right, so what is the value of P? We're going to go all the way here. We're going to use this equation, okay, because in that equation we know what P is. P is equal to 3 times our Q value plus 17. That is going to give me the value of that equation. Our Q is negative 4. So you can go ahead, and that is negative 12 plus 17. 17 minus 12. 17 minus 12, that should give you 5. Okay, so you have 3 times negative 4. Then you add 17 more to it, then you get your answer, which is 5. So that implies that P is equal to 5. All right. Of course, there are many ways you can do this. When you're solving this, I'm just checking and double check because this calculator is not allowed. So I don't think they will allow you to use this type of calculator. Simultaneous equations. I'm going to pick one. First equation, A is 3. This is the 3. It equal to our B value will be 2 over there. Our constant is 7. Go to the next equation. Our P is 1. Coefficient of that is 1. Coefficient of that's negative 3. So it's negative 3 over here. And our constant is 17. Okay. It equal to, it gives you the first answer. P is 5. Then the other one's negative 4. Right. This is the way that I'll go about to check that. Okay. So they will not allow you to use this type of calculator because you need to show your working. It's 3 marks over there. Right. The next question, the moment you are given fractions, your first thing that you need to do is put this in brackets. And they are sort of going to be cross multiplying that because the LCM, right? The LCM is just going to be those two brackets together. So that is 2x minus 1 and 3x plus 2. Please do not multiply out that. So, in order to have 2x minus 1 here, you need to multiply 3x plus 2 on both sides. So you're going to have 3x plus 2. That means top and bottom here, multiply 3x plus 2. And this side I have 3x plus 1 plus 2, so I need to multiply 2x minus 1 top and bottom. So 2x minus 1. Now you have to sort of remove, do not cross out. You only cross out when you have one term over one term. I can't. Then you're allowed to cancel, but here you can't cancel. Okay, so you have to multiply out everything at the numerator and see what is it that you are going to get. So the first one, that gives me a 9x plus 6 plus 4x minus 2. Very important that you see that. That is going to be my numerator. Remember I said the denominator should be written as it is. Don't do anything to it. Okay, this is just over 2x minus 1, 3x plus 2. Now you might ask what will happen if I was to, multiply that numerator, that denominator. Yeah, well, technically nothing, but I mean, it's unnecessary work and try to avoid those. Right, 9x plus 4x, that is 13x. And then you have 6 minus 2, that is plus 4. And then all this is coming over the same thing. And the reason why I wrote it so far, I was thinking maybe there's a common factor I can take out there. Since there's no common factor, then this is our final answer. Okay. Right, question 15. Let's see what we have over here. They say we are supposed to shade. Now, there's something very interesting about that. So we shade what is not in G with the union of what is not in H. I'm just shuffling around some papers that are in my way over here. Let's see how this goes. Okay. All right, let me see. What do we have? Like the way I like to answer this, every region I'm going to put a number there. I'm going to put 1 that is on the outside, 2 on the G, this side, 3 is like the intersection of that, and 4. And what I would like to do, I will write my G complement U union of that H complement. So what does it mean? So let's write down the stuff that is not in G. What is not in G is 1 and 4. You agree? So 1 and 4. Union, they will be together. What is not in H is 1 and 2. Right, so the union means togetherness. Okay, this is together. So you are going to, we're going to join that stuff. But we're not going to write something twice. So 1 must be written there 2 times, but you write it once. 1 and 2 and 4. Where you have 1, 2, and 4, that's what you're going to shade. Okay? So the shading takes place at 1, 2, and 4. So the only place that will not be shaded is where the 3 is. Right? Everything else will be shaded. Everything else, okay, will be shaded. And then you can just shade 1, 2, and 4. So the only one that will not be there is going to be this. All right, that's where you're going to shade. But don't waste too much time on this. I mean, you should not be spending a whole deal of time trying to find that for 1 mark. You can always do this when you are at the end of the question paper. Something interesting, though, about this one, just the fact that I thought I should mention it. This can also be written, in fact, this complement of G union H is the same thing, maybe you have guessed it, is the same thing as where G intersect with H complement. They mean exactly the same thing. So they could have given you something like that. Okay, you can try it out. You can draw yourself 2 of them and do the same. You'll see that the same area that you'll be shading. Right? So maybe if you are not aware of what I'm saying, let me just show you over here. I'm just going to enter a page, and perhaps I'm going to have my rectangle like so. And like so. Okay, slightly bigger. Right. Doesn't matter. Trying to be too perfect sometimes. Right. So let's say we have G and H. This is represented by G, and this is represented by H, and that is the universal set. Now, what I was saying is this stuff over here. Important that I say before I do encounter some problems. Take a snapshot. So this is what I'm trying to explain over there. I'm just gonna paste it over here. So let's say they gave us the question as this way. Let's say they gave us this, right? And let's see. Again, I'll start off by using my numbers. I put a number in every region, 1, 2, 3, 4, okay? And we're gonna have G complement of H, G intersection H complement, all of that, all right? So what is the stuff in G? G is 2 and 3. And then what is the stuff in H? The stuff in H is 2 and 3. Are you with me? Right. So first, I'm going to keep this because I need to do that. This one in the middle here, that is, you're going to read that every time as what do they share? They share a 3. Can you see that? They share a 3. So you shade everywhere except where the 3 is. That's what this means. You shade everywhere except where the 3 is. So you'll be shading everywhere except where the 3 is. So this is where your shading will take place. Right? This is where your shading will take place. Everywhere except where the 3 is. And you will be shading. That's what you use. There are obviously many other ways that you can do this, but this is for me, I find it easier to explain this to candidates using numbers, for those places. And that's it. And you will take note that this shading is exactly equal to that shading. All right, let's go to the next question. seem to be wasting a bit too much time. You are supposed to shade or to use set notation to describe the shaded region. Now, all of A is there. Since all of A is there, I'm going to say, okay, all of A, so it will be the union of whatever I'm doing here of everything in A. And then if I have to look after I have decided all of A, what is it that this region here represents? Only this region here. Well, that region represents the intersection of B and C. So it's B intersection with C. You can go ahead and put it in brackets. And that intersection with everything in A. Okay. Right. Next question, I see it's a question of functions. You do the first one. What are you going to get as an output when you include f of 3? So everywhere where you have an x here, you are going to replace that x with the 3. Okay? So that means f of 3 is going to be everywhere an x, right? So 1 minus 2 times 3. That's what you're going to do. This is just evaluation. Okay? So you evaluate, see what is it that you're getting when you do that. This is 1 minus 6, and 1 minus 6 is nothing but negative 5. Okay. Right, this one implies that you take all of f of x, always work from behind, from the back, right? So you take this, and the whole of this function, you are going to replace it where you have an x in the other function. That makes sense to you? So that means that this into that is going to be into that function. So you are going to say, okay, 1 minus 2x, 1 minus 2x squared. They say you must write it in the simplest form. I presume you're supposed to multiply it out. That's how you simplify it. This is more than enough for me, but you can actually go ahead and do that. So what does it mean? This is the same as 1 minus 2x, 1 minus 2x, and you can then multiply by expanding. I don't know if that is really in the simplest form. Don't agree, but it doesn't matter. All depends what your examiners are looking for. 1 times 1 is 1. 1 times negative 2x is minus 2x. Minus 2x times 1 is minus 2x. And then negative times negative, it's positive 4x squared. Okay, these two here are like terms. There are 2 of those, so it's going to be minus 4x. So final answer is 1 minus 4x plus 4x squared. Of course, you can write it other way around if you want to, starting with that. So you multiply this times that times that, and then you multiply the second term with every term in this first one, and that's how you end up with that. Right, so we need to find the inverse of f. So let's just write f of x over here, which is 1 minus 2x. And how do you find the inverse of that? Well, you can let the f of x replace it before y if you want to, 1 minus 2x, and then you switch the letters around. So you're going to have an x over here, and you're going to say is equal to 1 minus 2, and over here you're going to have the y. So your objective is to make y the subject, so it's going to be x minus 1 is equal to negative 2y, and then to get y, you're going to say all of this x minus 1 should be divided by negative 2. Now, that negative 2, you can leave it like this. I mean, for the negative part, not for the whole thing. I can put that minus on top here. And if I do that, and I multiply out the x, the 1 becomes positive. So the inverse, you cannot use y anymore, the reducer method, is going to be 1 minus x. That is that numerator if you multiply it out by the negative all over 2. All right. So it doesn't also matter. I mean, if you not to do that and you simply divide by 2, your answer will still be correct. Mathematically, it's the same thing. Okay. Solve the equations, the two equations, right? What was equation f? Equation f is 1 minus 2x. And what is equation g? Of course, equation g is x squared. Okay, let's make sure the functions. 1 minus 2x minus x squared. So you have to solve this. The moment they say give your answer to 2 decimal places, this becomes a quadratic equation because everything should equal to 0, and it will not factorize. So you have to use completing the square, or you have to use the formula. Okay? Right, so I'm going to move everything to the right-hand side. X squared, that 2x becomes positive 2x, and that is minus 1. Now, the way I like to use the quadratic equation formula, you have to identify what is your a value. A value is 1. Your b value is positive 2. And your c value is negative 1. So the thing that I'm going to do, I like to work out the part of the quadratic formula. I'm not taking all of it. Remember, the quadratic equation formula is x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. But I'm just doing this part here. That's how I like to do it, okay? To see what is my answer that I'm going to get there. To show you that anything under the square root, if it's an irrational number, then an irrational number, the answer won't stop. That's things like the square root of 15, okay? This number will never stop. It goes on, right? But if you have a number like, let's say, 49, 49 is a square number, that answer stops. So your answer will stop. In such a case, if you have something like that, then they will not tell you to give your answer to 2 decimal places. You will probably be able to factorize. Of course, you can still use the quadratic equation formula. So I like to use that b squared minus 4ac first to see. Our b is 2 squared minus 4. Our a is 1, so no need for me to write 1. Our c is negative 1. This answer is 4 plus 4. Okay, that's 2 squared plus 4. Okay, that is 8. Okay, you can check on it. Okay, that's 2 squared minus 4 times negative 1. Okay, that's give you 8. So the square root of 8 is going to be a number that doesn't stop. Okay, let me perhaps just do that over here. So one of my solutions, if I have to do my substitution, one of my solutions, or I can write them together, x is going to be minus, what is my b value? From there, I know b is 2, so no problem. I can just remember that if the moment b is negative, then you have to remember this is going to become a positive. Plus minus square root of 8, because I already calculated, and over 2, because a is just 1. You can go back there. So you have 2 answers, and you can just use your calculator now to find the answer. So I'm going to use my calculator. I'm going to say, okay, one answer for x will be negative 2, let's say plus the root of 8 over 2. Then I'm giving this answer to 1 decimal place. Just going to write it over here. So that will be one answer. Okay. That's when it's plus. What is my next answer? Then I'm just going to go back over there, and I'm just going to make that a minus. And take that answer. And clearly you can see my 2 values. So now I'll give my answer to 2 decimal place. That's to 2 decimal place, right? And you can now just go ahead and write the answer down. So it's going to be the first one, doesn't matter which one you write first, it's 0.41. The other one is negative 2.41. Those are my 2 answers correct to 2 decimal places. Okay, right. But of course, you have got all the right in the world to use the quadratic equation formula. And then you just start substituting right from the beginning the values of A, the values of B into that formula as long as you get to the answer. Just to show you something quickly that's really cool about this calculator that I'm using. It can actually do it for you, right? So this is my 1, that's my 2, that's my negative 1, or my values of A, B, and C, right? So if I go to that equation function, and I choose the third option because it's ax squared plus bx plus c. Third option, our a is 1, so I hit a, then I press enter or equal to. B is 2, so I'll be putting 2 there, press equal to, and c is negative 1. If you press equal to again, you have one answer. Remember that answer is here, 0.41. There's one answer. And the other answer, if you press equal to again, and let's just go back, One answer is that. The other answer will be the negative of that. So if I press that, can you see? I get that answer. Right. So that's exactly what it is, which is kind of cool if you get my drift. Okay. This is really going to help you to find. An interesting fact, why there is that -1 minus 2. I'm just going to append the page just to show you that. Of course, you don't have to really know, but sometimes you might ask yourself, why is my calculator giving me such type of answers, right? So one of the answers from my calculator was x is equal to 1 minus the square root of 2, or x is equal to 1 plus the square root of 2. Just make sure. Yeah? It's -1. It's -1, -1. Okay? Let's see. Is it the same for the other one? Of course, -1. Minus. So this is supposed to be a minus over here. I'm going to show you where that comes from. So let's take this that I have over here. So that is I'm going to write them separately. So you have what x is equal to -2, let's say plus the square root of 8 over 2, or x is equal to -2 minus the square root of 8 all over 2. Okay. Now, if you look at the number 8, 8 is nothing but 4 times 2. So if I have to do 8, the square root of 8 is the same as the square root of 4 times 2, or the other way around, 2 times 4. 2 times 4. What we know is we can take the square root of each thing, and if you do that, the square root of 2, or the square root of, let me not switch them around for the purpose of what I'm trying to explain over here. So let's just continue with leaving it as 4 times 2. That is the square root of 4 times the square root of 2. The square root of 4 is 2 times the square root of 2, and that is just 2 root 2. So this 2 root 2, right, that is where I'm going to have that 8. So I'm going to write over here this stuff. So this is becoming something like x is equal to -2 plus 2 root 2 over 2, or x is equal to -2 plus, no, that's not plus now, it has to be what? Now it has to be minus 2 root 2 all over 2. Okay. Now, let me just make space here. So I'm going to continue underneath. Right, so what is it that you're now seeing? If you were to separate them, right, the first one, if you were to separate them, it will be x, that means -2 over 2 plus 2 root 2 over 2, or x equals to -2 over 2 minus 2 root 2 over 2. Guess what happens when you are now cancelling out the 2's? This cancel, leaving you with -1. This cancel, leaving you plus root 2. Okay, or again, x is equal to this cancel, leaving you with -1. This cancel, leaving you with this. Can you see those answers? Those answers that the calculator is giving you, right? That's basically where it comes from, right? One is positive, one is negative. Good. Thought it's just an interesting thing that I should share with you. Let's go to the next question. Let me see if that was question 16 over there. Of course, now I have to move. Look like the paper still has a lot of questions. So this is a question on similarity. Corresponding sides are they're not equal, but they are in the same ratio. That means whatever there's a certain number I multiply 2.8 with to give me 3.2, or a number that I divide 3.2 with that gives me 2.8. I'm going to call that number k, where k is, let's take, because I'm looking for the big value, so I'm going to say that 3.2 divided by 2.8, that will be my number. So I'm going to say, let's just make sure that this is back to calculate computation. So I'm going to have 3.2 divided by 2.8, all right, 2.8, so that is my k, which is 8 over 7. So if you were to take this this number over here, the small one, if you were multiplying this number, if you multiply this number by 8 over 7, okay, you can have a look at it. So if you take 2.8 and you multiply it by 8 over 7, you are going to get that answer there. So I'm going to do the same. So I'm going to multiply this here by 8 over 7, right? Therefore, 1.61 times 8 over 7, that should give me the value. So I have 1.61 times 8 upon 7. Okay, what do you get? 1.84. So this answer here is 1.84. Just write it nicely. It is 1.84. And it should be bigger than that one. Can you see that? Right, anyway, next question. The diagram shows a right angle triangle, so you're supposed to calculate the value of x. You cannot use Pythagoras because you don't have two sides, so you have to use one of the ratios. So you can use only the sine ratio and the cosine ratio because the hypotenuse is given. You cannot use the tangent. Right. So where is this distance x considered from that? It's opposite. This is opposite. So that 56 degrees, is opposite. Um, uh, that angle is opposite to x. Can you see that? To that distance x, okay? So when we have got an angle and we're looking for that, so if you are having your sine ratio, your sine of an angle, let's say we call it theta, we don't know what the angle is always whatever is opposite theta, that distance, this is a distance, divided by the hypotenuse. So I have my sine of 56 degrees, which is a calculated value that I suppose you write it like this. What is opposite that? Well, it's the distance x. And what is the hypotenuse? It's 21.8. Okay. So the only thing you do here is you just cross multiply for you to find that. So you'll be multiplying this. That gives you x. And you multiply this. Okay. But put the 21.8 in front. So 21.8. Put it in front of that. Especially if you did not put brackets at that 56, it's going to be a problem. So 21.8 times, you don't even have to write times, the calculator will definitely know what is it you're doing. This is going to give you the value of x, right? That's going to give you the value of x. So let's see. Make sure your calculator is in degrees mode because the angle is in degrees mode because you're finding the sine, the relationship of that angle. So you'll be saying 21.8 times the sine of 56 degrees. Now that answer is 18 point and it makes sense because it cannot be longer than 21.8. Alright, so this is the answer. And did they say to what they didn't specify to what degree of accuracy you're supposed to give your answer to. And now you are going to activate what is the instruction in front of the question paper. I believe let's quickly go to that. So this is not an angle size, it's a distance. So if the answer is not exact and it's not specified in the question, then you go ahead and you give your answer correct to 3 significant figures, I believe. So let's just quickly go back to our instruction. And this is what I'm looking at, right? If the answer is not exact, the degree of us not specified in the question, as in that case, and the answer is not exact, then you are supposed to give your answer to 3 significant figures. If it was an angle, we would be giving it to 1 decimal. So that one has to be given to 3 SF, 3 significant figures. So that is going to be 20, it's going to be 18.1. So this is where I am. So to 3 significant figures, it's 18.1 centimeters. 18.1. Right, 18.1. Good. Next question. They say the equation of the line is equal to y equals to 2 over 3x minus 7 over 3. Okay, the coordinates of the point where you have to write down the coordinates of the point where this line crosses the x-axis, the y-axis. So if this is your Cartesian coordinate system, if this is our x-axis and if this is our y-axis, and this line is having a positive gradient, okay, so I must just extend maybe something like so. So if I was to draw a line, that line is going to go something like either like that. It depends on where it crosses it crosses the y-axis at positive, where the y-axis at negative. So the line is going to go something like this. You get it? So for 1 mark, there's a reason why it's 1 mark. The point where this line crosses the y-axis, that point x is 0, and you find it from the equation y equals 2 over 3x plus c. This plus c is known as the y-intercept. So that's the point -7 over 3. But we can calculate that point, right, by making, if you put 0 for x, if you put 0 there, then you're going to left with that. So they say write down the coordinates of the point where that line crosses the y-axis. It's 0, comma, 7 over 3. And they say write down, there's no calculation involved. Make your life difficult. Then they ask you what is the gradient. Um, the gradient is obviously going to be that value of m. So if you have this in gradient intercept form, the m is the gradient, and the m is, you guess it, 2 over 3, right? The instruction is still write down. There's no calculation involved. The gradient, m is equal to 2 over 3. Or if you don't want to write the m stuff, just write 2 over 3. That's what you have. Do not change it to a decimal. Then they say the equation of the line that is parallel. Now, parallel lines, so the equation of this line, number 1, the equation of this line is y equals to 2 over 3x. So I'm just going to write it here. The equation is y equals to 2 over 3x minus 7 over 3. Okay, that x looks horrible. Okay. Parallel lines, here's the thing that you should know about parallel lines. If you know what I'm meaning or what I'm going with it, maybe you definitely have an idea. Parallel lines have, you guess it, equal gradients. So the line I'm looking for will be y equals to 2 over 3x. But what else do I know? The line crosses, it crosses the origin. So at the origin, the value of, it's just going to be 0. So this line that they are talking about, this line is going to be, my goodness. This line is going to be parallel. It will go like this. It will be parallel like the other one. Okay. It will just pass through the origin. That's what it is. That's how that line will be. Same like this, passing through the origin. That's what you have there. So y equals to 2 over 3x plus 0, because the origin point there is 0, but you don't have to write plus 0. Question 20, they say find P, okay, say given PR is equal to -2, 1 on the grid represents PR. So what you have over here, the top component, this one gives the x direction, and the bottom one gives the y direction. This vectors, right? Y direction. So if x is -2, then you're going to go to the left. So this is going to go 2 places to the left. If y is +1, you're going to go up, right? So represent that. So as a vector, it will be 2 places to the left, 1 place up, north. Okay. Maybe we can change the color of that. From here, I'm going to go 1, 2 places then, and y is positive, so we're going to go up. If y was negative, it will be going down. So that is where that point is, and you can actually go ahead and say that is point R. 1 mark for doing that. Right, what do we know? They say PR, which is negative 2, 1 minus 2 times 1, 2. These are not fractions, so please don't confuse. These are vectors. And we need to take the distance of it. So let's do the stuff inside. The stuff inside, you're going to have negative 2, 1. Then you have minus 2 times 1 is 2. 2 times that is 4. Okay. You still have to take the you still have to calculate the distance, so it's guess this is going to be more than 1 mark. So this is going to be negative 2 minus 2, 1 minus 4. That's what I'm going to be using now. Okay. Still, we're going to find the distance of that. You with me so far? Right? You say top minus. You're just supposed to subtract the elements of each other. That minus that. That's what gives me this. 1 minus 4. That's what gives me this. Okay. So I'm just going to go ahead and I'm going to write it over here. I'm going to get negative 4 and negative 3. And now I'm going to have to take the distance of that. Right. So what is going to be the magnitude of the distance of that? Right. So of course you have on the grid, you're going from, you have negative 4. If I was to ask you to draw this on the grid, starting at any point, okay, starting at any point. Let's say we were starting. Let's say we were starting here. Let's say we were starting here. Let's say we were starting here, even here, all right, here. And I want you to draw negative 4. What is it? What? So it's negative. Okay, so let's make that point higher. Negative 4 point, negative 4, negative 3. So we draw a free vector is what we call it, starting from anywhere. So let's say that point was here. Just say that point is here. Right, so I'm going to go 4 places to the left because that x direction, that's 1, 2, 3, 4. And then I'm going to go 3 places down. It's 1, 2, 3. Here. This is represented by that. Okay, in fact, that's what that represents. So what is the length of that? Now, you will see that we are using this distance over here and that distance over here. So you guessed it right. It's like we're using Pythagoras. Okay, we want to use Pythagoras because this is a right angle triangle. So we're going to find this distance. How many units is that? Well, if you count, that's 1, 2, 3. That's just 3 units. How many? This is a right angle triangle. How many units are here? It's 1, 2, 3, 4. 4 units. These are the 4 and the 3 that you see over there. So we'll be using the theory of Pythagoras to find what this distance is. Okay, right. And you will see that the answer will be positive. Okay, so you're going to say negative, doesn't matter which one you start, negative 4 squared plus negative 3 squared. So it's like really having those negatives are not going to be there because anything you square is going to be positive anyway. And that's 16 plus 9, so that is square root of 25, and then your answer will just be 5 units. And the reason I wrote units, it could be centimeters, it could be, meters, they don't specify, so just like 5 units. All right. And you'll get the same answer if you were to take those 3 square, without having the negatives, and you use that on Pythagoras. You just say 3 square plus 4 square, take that, you're going to get the square root of 25, which is nothing but 5. So distance itself cannot be negative. That's why you have to consider that. Okay. So one of the biggest problem is the moment candidates are putting the stuff under the square root, they do not put these brackets there. And it's very important that you put those brackets there, because if you get an answer that is negative under a square root, the solutions will not exist, right? And then your answer will be wrong, and then you will wonder, what is it that I have done there? But you have seen it's like you put those negatives are not really necessary because we're talking about the actual distance. How many units are you going in this direction, that is in your y direction, or up and down? How many units are you going in your x direction, or left to the right? That is what we're looking for, and that is going to allow us to find the distance of that. So you cannot count those blocks like that because that's like a diagonal line. That's what that is, okay? Question 21, they are saying A, B, C are points in a circle. Write down the mathematical name of BC. I like this. It starts with a C. The mathematical name of that, right? That's a chord. Chord. Like a diameter is also a chord, but a diameter is a special chord because it passes through the center. Okay. So any line that touches the circumference of two ends is called a chord. Calculate the value of y. Now this angle here is going to be 90 degrees. This is an angle in a semicircle. So y is nothing but 90 minus 38. You can do all kinds of stuff. You can say 190 minus 90, right? And then minus 38 is still the same thing because if this is 38, that one should be 38 plus something to make this 180 because that's already 90. All right, so 52. So my y is 52. I'll also encourage you in the examination to write down, the stuff that you are working out, okay, as you are continuing. So a lot of you are seeing it many times, right? Then they say the area of the circle is 245.5. Now the formula to calculate the area of a circle is pi r square. You don't get a mark for writing that down, okay? Essentially, let me just put the a value on the right side. This is giving us the area. So what do we have here? We have something like this. So we have got pi times r is equal to 245.5. Okay. We need to know what the radius. We'll have to get the radius. Here's the thing. The radius is equal to whatever the diameter is, you divide by 2. So when you are looking for diameter, is you're going to multiply 2 times the radius, okay? So this formula is going to allow me to calculate the r, which is the radius, which is the distance from O to B, right? Which is the distance from O to B, or the distance from O to R. So that is, any one of these is the radius. But I'm looking for that whole AB, so it must be the radius plus the radius, and 2 times the radius is nothing but the diameter. So when I use the formula here, if I use the formula, I'm going to write it on the side because I'm running out of space. This, if I say r square equals to 245 divided by 5, not divided by 5, divided by pi. Whatever this answer is, I'm going to take the square root of that answer. And remember, the radius is a distance, so there's no need of putting plus or minus in front. It has to be a positive value, okay? And then I'm going to use the calculator value for pi. Of course, you can use whatever they give you in front of the book or the paper. I'm not 100% sure, but we'll just have a look what are they saying. What can you also use to represent the value of pi? Of course, I'm using the more accurate value, okay, which is that. So this answer is the radius. I'm just gonna do not round yet, okay? So paste it. This is my radius, okay? But now to find my diameter, I'm going to multiply this answer by 2, okay? So if you capture screen, right? It's kind of a bit lazy. So my diameter is going to be this value over here, okay? Right, but they want us to remember, give our answer to 3 significant figure is distance. So you'll be writing 17.8. So this is going to be 17.8 centimeters. That's what you're going to have. Right, so let's just quickly see. What are they saying for pi? What should you use? So it's going to be 3.142 anyway. Let's just go back to the instructions that I will advise you to get yourself, familiarize yourself with that. They say for pi, either use the calculator, like what I did, or you use 3.142. Do not use 3.14, 3.1. This is just an estimate. The value of pi is an irrational number. Okay, right. So let's go to our, I believe, next question, because we have done with this question. I believe so. Next question. Right, question 22. Gu Shua test new trucks. The probability that a truck is faulty is 1 over 25. So negating that, what is the probability that it is not? Negating that, you just say, okay, it's 1 minus 1 over 25. Okay, or 25 over 25 minus 1 over 25. What is that fraction going to be? It's going to be 24 25ths. Okay, write it like that. Don't try to go and write it as decimals and so on, but most probably you are not going to get penalized by the examiner, but the 0.96 is also an acceptable answer. But 24 over 25 is fine. Don't write percentages, okay? In 1 week, Ngushiwa tests 425 trucks. Find the number of trucks that are expected to be faulty. So faulty ones is 1/25, so 125, this represents the faulty one, so multiply by 425. We are looking for number of trucks, so your answer must be greater than, okay, because it can be between 0 and 1. This answer at the beginning must be between 0 and 1. So 1/25 or 425, you can actually multiply this on your own, or in your head rather, but it's 17. So the answer is 17 trucks are expected to be faulty, okay, of those. Okay, that's a very bad business model. They need to improve on that probability. But anyway, you get the idea. A teacher did a survey to find out how many subjects each of 110 students study per day. My God. There are 14 students who say they study 5 subjects, and there are 10 students who say they study 14 study 4 subjects, 10 study 5 subjects. If you add these frequencies up, then this is going to give you 110. Okay, you can just as well have a look at it, just to play around so you can see 3 plus 26 plus 57 plus 14 plus 10. What does that give you? 110. You see that? Okay. The mode is the one where the frequency is the highest, and that is going to be the mode is not 57. Okay, you're supposed to write the mode highest frequency, which is 3. So the mode number of subjects, this is what we are comparing. So 3 is the you don't write the frequency down when you ask that question. You have to talk about the subjects, the actual things that are being researched or surveyed. Mean, of course, mean you're just gonna add all of them together and you divide by 110. But it's 3 marks for a reason. So you're not going to say, how many of them study one subject. You say 3 of them. You're not going to write 3 plus 3 and 3 and 3. Right? 3 plus 3 plus 3. That means you have not 3, my goodness. You're not going to have 3 ones. That's what I mean. You're not going to do this. This is what it means, right? In a long way, and this is a fundamental waste of time. How many people are studying one subject? That is 3. So 1, 2, 3 people are studying that. How many people are studying 2 subjects? That's 26 of them. Okay, that's 1, 2, 3, 4, 5, up to 26. You say this is horrible. Not gonna work. Not gonna work. So how do you find that? You can say, okay, 1 times 3 plus 2 times 26, because there will be 26 of those, plus 3 times 57, plus 4 times 14, plus 5 times 10, and you're going to divide all of this by 110. Okay, keep on writing the stuff down, because you never know, you could be gaining marks for doing that. And now make sure that you get the correct answer. Okay, right, so I'm going to have, that is 1 times 3, that's just 3. 2 times 26, all right, 2 times 26, plus 3 times 57, 3 times 57. You see, I'm not putting brackets here because the calculator will know what to do. But some calculators, especially these old types, you definitely have to put those brackets. Where was I? 4 times 14. So that's 4 times 14 plus 5 times 10, which is just 50. All of that over 110. You get 166 over me just write down 166 over 55. Okay, and then you can actually give your answer to, you know, that implies that goes on and on and on. Okay, I'm just gonna make this 3 and 1 over, so the mean is very close, so I'm gonna make that improper, so I mean a mixed number. 3 and 1 over 55, acceptable answer. So it's very close, the mean is very close to the mode. All right, so this is telling you already that you can't have something else there, it must be the subjects that you are comparing. Now, let me just say, I multiply this by 110. So the 332 over 110. So you might be given 20 equal signs. You might be given an answer for that on top there, right? So because I know that, okay, wait a minute, 332 divided by, what is that? 110. Okay, that gives me that. So sometimes they might want to see that 332. Okay, whatever you do, that's what you are supposed to get as an answer. Okay, let's go to the next question. Hopefully, you know, I was told when I'm doing these videos that I'm supposed to work a little bit slower. Okay, so I'm trying to go as slow as I can. Right, so this is the part B of this, right? It's still statistics. The diagram shows, so it's totally a different story. The age distribution for a group of people who visited a local grocery shop on one Saturday. They don't tell you how many people there are. The histogram and table shows the result. Use the histogram to find the missing values in the table. Right, there's something that I am going to write over here. And I expect you to be able to work with me on this one. So we have something called frequency density. And I'm going to abbreviate it as FD. Then we have something called class width. I'm going to abbreviate this as class width. And then obviously we know frequency. Frequency. And I'm going to abbreviate this only as F. Now, how do you calculate frequency density? You take the frequency, you divide it by the class width. This is an important sort of formula that you need to understand. Okay, and I'm going to use it here. I know in this one that I have, the one that is completed for me, this one over here, I know the class width, I know the frequency. What is the class width? The class width is 40 minus 20. The class width here, the class width is 20. You agree with me? The class width is 20. What is the class width here? 20 minus 10, the class width is 10. So this one is class width. Okay, are you with me? Right? So I'm just going to take that off. So I'm just going to write the class width. Class width here is 20. 40 minus 60, 60 minus 40, rather 60 minus 40, the class width is also 20. 70 minus 60, that's 10. So that's the class width. Now, this one that is complete, I need to use that, right, to show you. I have the class width, I have the frequency, I want to calculate the frequency density, and that is going to help me in that diagram on top. So, for the complete one, right, the complete one that I have, let's say we say, okay, the frequency density is going to be the frequency, which is 16, divided by the class width, which is that. Now, write it as a decimal, obviously. There's a reason for that, okay? So 16 divided by 20 is nothing but 0.8. So this is 0.8. So when I go to my diagram, for the one class interval between 20 and 40, for this class interval between 20 and 40 here, 20 and 40, this is now 0.8. Are you with me so far? That's what you have. Now, you can see, if you were to take this class width, which happens to be, that class width happens to be 20. And if you take this rectangle and you say 20 times 0.8, guess what you're going to get? If you take 20 times 0.8, you get 16. So that's what I'm going to do for the other ones. but I need to find out what the other ones are. So how many do you have here? What does one little block represent? I have 1, 2, 3, 4 before I get to 0.8. So 0.8 divided by 4. This is going to give me, what does one little block represent? Of course, it represents 0.2. So this is 0.2, 0.4, 0.6. Then you have 0.8. So continue now and complete it. After 8, you get 1. Okay, 1.0. You can also write 1.0. Then you have 1.2, 1.4, 1.6. Now you can calculate the areas of all these triangles. Okay, this one you will now say, okay, I can actually calculate this one. What is the class worth? 60 minus 40, 60, that's 20 times 0.8, is it? Because 60 minus 40 is 20. No, not 0.8, rather, my goodness, times 1.6. Okay, that's going to give me 20 times 1.6. That's the height of that. That gives me 32. Let's do this one here. What is this one? This is 10. What is the height? 10 times 0.4. Okay, maybe not like that. You know, I cannot. So this one, that one is 10 times 0.6 rather, times 0.6. You understand? So you have got 10 times 0.6, 10 times 0.6. That's 6. And this one over here, we have 10, because it's also 10, times 1.2, which is just 12. And those are what we are supposed to put in those tables, those missing values. All right? Good. Right, so between 10 and 20, what is our answer? It's 6. Between this one, excuse me, this one is already given. Between 40 and 60, what is our answer? 32. 32. Between 60 and 70, what is our answer? 12. There you are. You are done. You have completed 3 marks, 1 mark for each one of those things. Right, question. This is the very last question. I'm also getting a bit tired. Anyway, let's see. Let's just make this one a bit smaller. Some children ask what their favorite sport is. The result is shown in the pie chart, okay? Right, so what I would like to do myself, I would like to find what is that missing value, okay, before I do anything, okay, before you read anything. So 120. Now remember, everything is supposed to be 360, right? So everything should add up to 360. So minus, you can say minus 80, minus 120, okay, or you can add them and subtract them from 360, the same thing. Minus 45, minus 60, okay, I have 80, I have 120, I have 45, or 60. Hit enter, that's 55. So this missing here, this one, is 55 degrees. Complete the statements about the chart. The sector angle for running, 55 degrees. The most popular sport is going to be the one that has the largest angle. And the one that has the largest angle is 120, which is gymnastics. Gymnastics. 2/9 of the children chose. Now this is 2 over 9. Everything is 360. So let's see what we get. Okay? Which angle are we going to get? So we take 2/9 of 360, 80. That is 80 degrees. And 80 degrees is what? Swimming. So go ahead and write. Okay? Next, I believe there's 5 marks. There's 2 more. Twice as many children chose. Twice as many chose. Now, which one is twice the other one? 120 is twice of 60. So they say twice as many children chose gymnastics as opposed to choosing hockey. Gymnastics, okay? So gymnastics as opposed to choosing hockey. as opposed to choosing what? Oh my goodness. As opposed to choosing hockey. There you go. So I do believe that, well, of course, the way I said I came to the end of this question paper, I just received it today, and I just quickly decided to work it out so that also you guys can do your revision on it. If there are answers that you are not agreeing, please do contact me, and or do indicate on the WhatsApp, on the YouTube channel rather. And I have posted the solutions to the past exam question papers as well. So I do expect you to make use of them right as you are preparing for your upcoming examination. I kind of like this paper. It was well said. It had everything that was needed, for you to know to prepare you for the end of year examination. So it was quite a nice paper. With time, I will be uploading paper 2 that was written, because this is paper 1. I believe paper 2 is the one that is 3 hours long. I'll be uploading that one as well. But I thought this was a teachable moment, so I can help you for you to see how you are supposed to address questions of this nature. All right, address questions of this nature, so make it a little bit easier for you. Right, and I'll be uploading this somewhere in the midterm, which is going to be somewhere next week. So I'm giving everybody the opportunity, right? Okay, to mark and so on. So, good luck with your studies. You must stand by for paper 2 that I'm going to be uploading very soon.